Thank you, Matt, and thank you to the University of Chicago for hosting this event today. It is truly my pleasure to be here with friends of these world-class institutions and to provide a very small overview of what is truly an enormous global challenge and opportunity. That is urbanization. So I'm here today to talk about the promise of science and engineering alongside close interdisciplinary partnerships to improve upon one of humans' greatest inventions, and that is cities, or as what we refer to as urban system science and engineering. So unlike some of the other talks that you'll hear this morning, this is not a traditional scientific discipline, nor am I a traditional scientist, but this is a relatively new endeavor, given recent advancements, particularly in data and technologies. So when I first started thinking about urban systems, I did what almost all of us here in this room would do, and that is I read a lot. I read everything I could get my hands on about what's been done and what's been written in the urban science space. And there was one line that really truly captured my imagination. And I want to share that with you today because maybe it will do the same for you. And that is, a city is first and foremost a social reactor. It works like a star, attracting people and accelerating social interaction and social outputs in a way that is analogous to how a star compresses matter and burns brighter the faster and bigger they are. These are two images that I found almost artistic in some ways. On the left, of course, you see an image from NASA of stars, and on the right, you see Tokyo. So I think that this is one way to start framing the discussion and start thinking about what is it that we truly know or maybe don't know about the cities that we live and work and play. Now, of course, the mathematics are quite different, but nonetheless, I think it's an inspirational way to talk about cities and truly frame some outstanding questions. So my objective here today is that you will leave here thinking of cities as more than just places that you live, but cities are complex networks of systems that include flows, relationships, and interconnectivity in time and space. So you might be thinking to yourself, cities have been around for a very long time, so why now? So let's try to build a framework for this conversation. So if we go back 150 years, there's an interesting story to tell, and we hear this quite a bit, that urbanization is happening now. But I actually want to offer all of us a bit of a dose of humility this morning. Quite frankly, urbanization has been going on for a very, very long time. It was approximately 12,000 years ago that humans figured out how to farm and domesticate animals, and that truly enables all of us to be here today because we no longer have to hunt and gather for our food, and that allowed us to actually create cities. So we see the first cities starting to move a very, very long time ago. Now, of course, you can read these statistics, but nonetheless, we see urbanization happening at a rate that has never been recorded in history, and this is mainly in the developing world. So, needless to say that this urbanization across the globe will require thousands of decisions to be made in a very short amount of time that will impact citizens for generations to come. It is therefore crucial that these tools are available to decision makers to create the best urban centers that we possibly can. So, the panel earlier talked a little bit about China, which I think is great and timely. To put that into perspective a little bit, it's going ahead without me too. In 2025, approximately 70% of Chinese people will live in cities with 1 million people or more. And by 2030, 221 Chinese cities will have 1 million people or more. So of course, we know that there's a strong push in China to actually add city dwellers. They are moving approximately 400 million city dwellers, moving rural people into cities. And if we put this into greater context, that means that China will need 40 billion square meters of floor space in the next 20 years if they are successful in doing this. This means the equivalent of adding one New York every 2 years. So I have another confession to make here today, and that is that cities for the sake of cities doesn't really get me that excited about the research, but cities are key drivers of some of the most critical issues facing humans. And for the purpose of this morning, I selected 3 that I am personally most passionate about. The first one is climate disruption. And why that? Well, it's widely reported that cities produce 70 to 80% of greenhouse gases, yet this doesn't always give the full picture. In many ways, city dwellers are often less carbon intensive than rural and/or suburban residents, and the way that we develop cities in the future will be the key challenge, and we think science and engineering can play a key role in designing these cities. Moreover, we know that cities across the world are setting goals to reduce carbon dioxide and other greenhouse gas emissions, yet this is very difficult to quantify, measure, and track, and we think science can help with that. Next, energy security. In the United States, for example, we have about 640,000 square miles of transmission lines. The issue with this infrastructure is that it is dated in many ways, and it's poorly equipped to handle new technologies and consumer interests, such as distributed generation. We think science can help. And then lastly, economic vitality, which was talked a little bit about earlier as well. On average, as a city size increases, per capita socioeconomic quality, such as wages, GDP, number of patents produced, number of educational and research institutions, all increase by approximately 15% more than their expected linear growth. Same thing for some of the negative things, like crime, traffic congestion, but we think science, along with our partnerships, can help. So the takeaway here is that given cities' critical nature, we need to look at cities as multi-scale, complex, dynamic, and interconnected systems. Science and engineering can help, but what does it actually look like? So I'd like to present to you today some examples of the work that's going on at Argonne and with our partners. It was very hard to present some of these examples because there's so much going on in these spaces, but I selected examples that are unique to Chicago. So the first one that I'd like to talk a little bit about is our role in a great project in partnership with ComEd. They're the ones leading this project. This is looking at a way to develop an advanced microgrid. And what's especially unique about this project is that it is linking two microgrids together. So there's an existing microgrid at IIT, and there's a new microgrid being built in the Bronzeville area. And our goal is to develop the advanced algorithms and modeling to be able to do this in a new and different way. So I also talked a little bit about climate change. So one of the things that I think is most interesting at the work that we're doing at the lab is an ability to model climate change at a more granular level. So one of the things that we did when we went out and we started talking to cities was we said, what are you thinking about? What are you worried about? Without a doubt, the cities that we talked to said, we're worried about climate disruption. We know it's real. We know it's happening. We don't know what that means for my city. So what we were able to do is use what's called representative concentration pathways, which is essentially greenhouse gas concentrations and trajectories that were adopted by the Intergovernmental Panel on Climate Change. So we did this for the Midwest region. We could definitely get more into this, but suffice to say that if there is no change in greenhouse gas concentrations, the Midwest region will look both warmer and wetter as we go forward. If we break that down to Chicago, even more specifically, we can actually see some different scenarios in data. Again, the main takeaway here is that if greenhouse gas concentrations stay the same, we'll certainly see temperatures rise, and we'll see more precipitation as well. So traffic flow, that's something that I'm personally very passionate about, living in the city and working at the lab. It's something that we can model at the laboratory using complex adaptive systems. So what you're seeing here is an animation, but it's extremely advanced mathematics and algorithms behind this animation. And what we do here is actually model each individual car or bus or train, whatever the case is, as an individual agent. And then we allow those agents to interact and are able to see how different scenarios could potentially play out, both with interventions, technologies, or even, for instance, looking at how we could evacuate the city more effectively. Same thing for disease spread modeling. It's another similar model that we use. We use complex adaptive systems to study how diseases can travel through a city. As we've looked throughout history, we know that diseases in some cities flourish because of human contact, others die. This is actually a simulation of a MRSA model going through the city of Chicago and looking at how different agents interact given their contact and how a disease could spread throughout the city. So that leads me to the future, and how do I see us going forward? Well, the future is truly in both basic and applied science to truly advance our understanding of how cities work, and we need to do that with the user facilities that we have at the lab, and of course, most importantly, the exceptional minds and people that we have at the lab. And then because this is truly an interdisciplinary problem, we need exceptional partners with people that are here in the audience today. So from the lab to the city, we see this as the key to our success. Here are just a few key partners that we're working with on this issue. There are many more, but this is just a few to illustrate the example. So let me close by saying that innovation is driven by collaboration, and collaboration requires smart, diverse, and creative people. That is what is in cities, and it's precisely what is needed to truly understand cities. Thank you very much, and I'm happy to take questions and ideas.
Questions for Leah? You talked about 3 criteria, the climate, disruption, economic vitality, and so on. Is it possible to score cities on how they're doing vis-a-vis those things? And what's the best city?
Chicago.
Yeah.
Thanks, Matt. That was a good one. Yeah, so clearly there's a lot of that going on, and cities are trying to do that. You see all sorts of different index measurements that are going on. I don't know that there's really a best way to do that, and I think that actually speaks to the true nature of cities. If you measure for one thing, you're almost inherently not measuring for another. So to say that there's kind of one best city out there, I don't really think that that's the right approach. We need different cities to do different things.
Tim.
I just wanted to build on that a little bit. So you showed some examples of Chicago City. Are there key features of Chicago as a city that distinguish it from other cities in these modeling? You know, Chicago City traffic got a different mathematical approach than, say, New York traffic? Or so are there fundamental differences in the framework that start to distinguish cities? Or if you develop a model, you can apply it to many cities?
Sure. Well, I think for the transportation piece, what you start to see there is more of, we're on a grid, obviously. So how people actually respond to that grid is probably a little bit different than how you would maybe see traffic or complexity chaos in a city like Boston, for example. So you do see differences. But in general, every city will have some unique features. I do think a key part to this research initiative is to understand what is universal and what are kind of key ideas that are true to cities kind of across the globe. I mentioned the 15% increase. That typically in research, that tends to kind of be pretty universal across most cities. So we're trying to look for those things, trying to discover those things. With that said, of course, every city will say they're different.
Nigel has a question here.
You mentioned that China was clearly one of your slides of people moving into the city. Do you view them as being very proactive and progressive about how to create cities and how to deal with the issues in cities compared to, say, the West?
It's a great question. I think that's unclear right now. This is a relatively new and fast-moving issue that we've seen. So I think kind of how that plays out and what we'll see is still to be determined.
Last question. Again, yeah, nope, that's it. We have time for one more, so go ahead, Eric.
So as you build up these models
Yes.
and answer some of the challenges in traffic or in carbon, et cetera, what kinds of partnerships, these are great to have the models and to point out to the cities, here's what you're doing right, here's what you're doing wrong. What kinds of partnerships do you need to develop to ensure that these are adopted as policy or adopted as programs in the cities, and how are you thinking about that?
So we're thinking about ways, and what we're doing is actually formally partnering with cities. So I mentioned the examples in Chicago. We spend a lot of time talking with people in Chicago. We're doing similar work in Detroit, which I think is very exciting because we actually have a lot of latitude there to try new things. But to suffice to say that actually to be and work in cities is a critical part of this. And models are great, but the best models essentially tell you how wrong they are. And that's very important when informing policymakers.
Good. Thank you very much.